Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So this is a continuation of our IPRAN training series, and in this episode we'll be discussing how to segment different mobile services on our IPRAN network. So we know that the main objective of deploying the network, the main objective that service providers will acquire the routers, do the installation, do the decommissioning, ensure there is connectivity between different nodes, and even going ahead to deploy different protocols. Like we have discussed, we have IGP, SIS or SPF, and we have BGP and MPLS that are all deployed on this network to ensure that we are able to deploy different services on this network. So the main objective is to be able to provide different services that our users require. We know that users need to make calls, so they will be using 2G, 3G, or even 4G VoLTE for making calls. They also need to be able to access the internet and browse different applications or access different services that are provided over the internet. So we need to be able to provide these services to the users, and we should provide high quality services to our users. Even institutions like banks will set up their network to be able to provide banking services like the money transfer, money withdrawal to their customers. So that is the main objective of setting up or deploying these networks. So we have discussed that with this IPRA network, we have a connection to the BTS, the radio equipment at site, which is connecting to the CSG. And then we need to ensure that we are able to reach the controllers, the 2G, 3G, the BSC, the RNC, and even the 4G controllers, which will be able to have end-to-end reachability between the radio equipment and the controllers. So with the normal network, we have mentioned that we are deploying MPLS on this network. So we have the CSGs connecting to the BTS. So the BTS will be acting as our customer edge devices in a normal MPLS network. And then we have the CSGs. The CSGs will be the PE nodes. So the CSG has to learn routes from the BTS for different technologies. And once it has learned the routes from the BTS, they have to propagate these routes to the RSG to the controllers. Even the RSGs will be acting as the provider edge routers. Remember, they are also connecting to the controllers and also to the BTS. So we need to have a mechanism that we are able to deploy all these different technologies on our existing networks. We don't have to deploy a different or a separate network for 2G, a separate for 3G, a separate for 4G, and even a separate network for 5G. So they should be able to share the existing network infrastructure and be able to provide all these services to their customers. And we know that different technologies, for example, 2G, 3G, and 4G, 5G, they have different requirements. So they have different requirements in terms of delay, packet loss, and we need to be able to provide some preferential treatment to these services so that we meet customer requirements. When a customer is making a call, the call should be able to go through without any delay, should be able to go through without any packet loss. So we need to give some preferential treatment to some of these services, and that is the reason why we are coming up with VRFs. So we are trying to separate these services and give them some preferential treatments. So on the service provider networks, we use what we call the VRFs, or the virtual routing and forwarding on Cisco. On Huawei, we are calling them the VPN instances. And then on Nokia, we call them the VPRN. So these are layer 3 VPNs, and in simple terms, we are creating some logical routers within the main router. We are separating these services into different routing instances, and with that we are able to give them some special treatment so that we meet their requirements. So we will create different VPRNs or different VRFs for different services and segment them so that they are separate from each other. So we'll have different routing tables for different services. And remember, even with these 2G, 3G, 4G, 5G, we also have the signaling and the data. So we also need to segment the signaling. Remember, signaling will require special treatment compared to the normal data. So we have the signaling that will be put in different VRFs or the VPRNs, and then the user plane will also be in different VPRN. And another thing that I need to mention also is that we have the O&M. We also need to have a VPRN or a VRF for the O&M of the sites. Remember, we need to be able to manage all these sites. So we need to create different VPRNs for different services and segment them so that they are isolated from each other. Then we can meet the requirement of giving them some special treatments. So with the service provider networks, remember before we have discussed that we have different regions. We have the network segmented into different regions. And these regions could be having controllers. For example, you will find that region 2 will have its own BSC and RNC. Or even it could be having its own 4G and 5G controllers. And then region 5 will also have its own controllers, for example, BSC, RNC, and even the 4G controllers. So we need to be able to localize some services. We need to be able to localize the 2G and 3G services for different regions so that a user who is in region 2 doesn't have the 2G services from a user who is in region 2, doesn't have to traverse all the way from region 2 to access a controller in region 5. All those services can be localized within a given region. And that one makes it easy to manage and even to control the traffic flow between these regions and even offer better services to our users. So I've mentioned that we'll be using VPN instances. On Huawei, we call them the VPN instances, the virtual private network. So we'll be creating different VPN instances for different services. I mentioned that we'll create a VPN instance for O&M, we'll create a VPN instance for 2G, 3G, 4G. We normally separate the signaling and the data. So we'll have a one VRF for MME, and then we'll have a one VRF for the user, the control and the data plane. So on Huawei or Nokia, we call them the VPRN. So with VPNs, we know we have two key concepts. We have the route distinguishers, and then we have the route targets. So the route distinguisher, the main objective of having the route distinguishers for VPRN is to be able to use overlapping addressing space. So different users or different regions can have overlapping addressing space, allowing us to efficiently use the available addressing spaces. So with the route distinguisher, we are able to allow customers to use overlapping addressing space. And then we have the route target. So we have mentioned that we need to ensure that we have route exchange between different PEs and even between similar VRFs. So what we do is we use route targets to control the import and export of the routes. And then once we have set up our VPNs, we end up having different VRF table or different VPN instant routing table for different services. So the way we plan our route distinguishers is we have the AS number and then we give a random number at the end. So it's AS:X. So X will be a random number, and then it will be changing when we are configuring different VPN instances. So we'll have a different distinguisher for 2G, we'll have a different route distinguisher for 3G, 4G, and 5G. And these route distinguishers will be even different in different regions. Remember, we have different regions on the service provider network. So we need to do a proper planning for the route distinguishers so that we don't end up having overlapping or repeating route distinguishers in the network. Then for the route targets, we also use the AS number. So for example, if you have a 65511, that one will be the first part of the route distinguisher of the route target, that is. And then we also need to have the other part. So we have the AS:Y. Y will also be a unique number. And for you to be able to exchange the routes, remember, you need proper planning for these route targets. So we have the import and export. So when the CE or the PE is advertising the route to the other PEs, they will be checking the route targets before they can be able to learn these routes into their routing table. So you really need to do proper planning for the route distinguishers and the route targets on the network. And then once you have these VPN instances running on your network, we will have different routing tables or different routing instances on the existing router. And then we'll have the public. So the public routing table will be separate from the VRF routing table. And the routes for different technologies, 2G, 3G, 4G, and 5G, will be installed in different VRF tables on our routers. So we achieve service segmentation by using the VPN instances, the VRF or the VPRN on our IPRAN network. So this is how we normally do it on the service provider network. We use the VPN instances, the VRFs, to be able to segment these services on our physical network infrastructure, and we can be able to provide some preferential treatment to some of these services and meet customer requirements. So thank you for watching. This is the end of this episode, and in our next episode we'll be discussing how to do VLAN and IP planning, and then we'll have a lab simulation just to show how we are able to deploy these services on our IPRAN network and achieve end-to-end connectivity and even be able to provide these different services to our customers. Thank you for watching again, and please remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.